We're going to start with a quick review of functions, but we're not going to spend a ton of time on that because we have a separate video that handles functions in more detail. You can see that at mathmusicandmore.org and look for the intro to functions. We'll cover it briefly so we can spend more time on charts and lines and slope. But a function is just a sort of like a box. It's sort of a machine with a crank on it, and you can drop something in and you turn the crank and you follow the rules or whatever machinery is in there and you get something out. And the only other thing that's noteworthy with functions is that for any given one input you get one output. You shouldn't expect to get two outputs for one input. So what we'll do next is we'll look at an example, and again we cover more of the details in another video, but we use x for input, and then we're going to look at something like x plus 5 as an initial example of a function, which means you're going to take x and whatever it is, whatever number you put in for it, sort of a substitution, you then add 5, and that means that y is then what you would get out. And in this case, that's what it could be stated as f of x, and again we cover that in the other video. So what we want to do now is start getting into what we're really interested in, is starting to look at some numbers and look at what happens with lines. We're going to stick with lines on this, but let's take this a little further than we did before and look at the coordinates. So we'll start by looking at this center one in case you're new to this. So the center one is a case where we dropped a 0 in the machine, and then when you go to turn the crank, so to speak, you would then take the x, put a 0 in place, and you get a 0 plus 5 as what the operation is going on in here, and then what spits out is a 5 if you put a 0 in. Now the 0 case I've highlighted is a special case for lines. It's the one input that will tell you the so-called y-intercept, which we'll look at later. But if you notice, there's other values here that have been picked for dropping them in, and they're random. It's whatever interval I happen to pick, 8 in this case. But so if you have different inputs, you're going to get the different outputs, but you notice it's 1 to 1. So if you put this in, you'll only ever get this out with this function. Same with 8. If I take 8 and plug it in, I'll only ever get 13 out with this function. So what do we do with these numbers? Well, what you can do is you can consider each pair of input and output as a single thing we call a coordinate. And we call it a coordinate because it's essentially a point that we can look at on a chart, and we can chart this information. You don't have to chart functions, but it's really informative to do so. So anyway, so we call the pairing of an input with an output, we usually write them this way with parentheses and then a comma between them, and we want the first one to be the input, which in this case is the negative 32, and we want the second number to be the output, which in this case is a negative 27. And so on. All of these points are written with the same rules. So what we want to do next is go ahead and take a look at a chart and see what this looks like. So let's look at, and then we'll be talking about slope more because then we can actually see it. So here's a chart that has this information right here on it. And first thing to notice is this yellow point. That's where we started before, so let's start there with the chart as well. So if you recall, this point is 0, 5. I have these coordinates listed under the point. This looks like it's next to the yellow, but it's 0, 5. So the 0, 5 goes with this. So 0, 5 is the yellow coordinate, and what that means is the 0 means how far am I going to travel along this blue axis first. That's how far, that's which direction and how far I travel. And then the y number is which direction and how far do I travel vertically. So since the first number is 0, we're going to stay right here in the center on the left, right. And then the 5 says to go up 5, so that's why we end up right here on this point. And as I mentioned earlier, this is that special point that actually reveals the y-intercept, which is 5 in this case. And that's because that is the y value where the line crosses the y-axis. And I've noted here that the b is 5. If you remember, there is a formula for lines, and this y equals mx plus b form can describe all lines, I suppose, except for the vertical one. which we'll not talk about today. And then m is the slope, which is the tilt. And in this case, we have x plus 5. It's not real obvious at first what the slope is because there's nothing in front of the x, but there is something in front of the x. It's just a hidden 1. So remember that if you see x plus 5, the slope is there. It's not 0, because 0 would just mean it would be y equals 5, which would be a horizontal line, which would be a 0 slope, actually, which makes sense because that's 0 times x. So something that might be informative here is to start thinking about what a slope value means. So the slope of 1, slope is also defined and viewed as it's basically rise over run, or meaning divided by, or change in y divided by change in x. So to figure out slope, you need at least 2 points to figure out what's happening. And what might not be immediately obvious is that since it's a straight line, you can pick any 2 points you want. So you could pick these two, or you could pick the end ones. You will get the same slope because it is the same line. And the slope never changes with a line. It is what it is. In this case, the slope is 1, which means if you take 1 point and move to the next one, you will have risen the same amount that you run. And I tried to make sure that the chart here stays with an even division left, right, and up, down, so that a slope of 1 looks correct, which is essentially across the corners of the squares. It's 45 degrees. A slope of 1 is exactly 45 degrees, which is right exactly between. Any slope bigger than, excuse me, any slope bigger than 1 will tilt more. So for instance, if we were to take this and make it 2 times x plus 5, the slope is now 2, and you can see it got steeper. And if I instead go below 1 and do something like 0.5x, now you can see that the slope is now less than the 45 degrees. So 1 is sort of a pivot point, 45 between the 45s. Everything above 1, and that goes way up. So if I go real steep, let's do a slope of like 15. You can see it gets steep really quick. And then what about negative? Well, I can also do a negative slope. That means it's downhill to the right. This is a negative 1, so it goes at a rate that's the same as going across the corners of the squares. Now again, it can be shifted up or down. If I were to have a y-intercept that was at -5, that would mean that this line crosses down here at -5 on the y-axis. So I hope that this has helped you visualize lines and what they mean. And the only other point I would make is that these points that we've chosen for these dots are just sample locations. The green line actually shows the infinite number of points that make up the line. So no matter what x you pick, you'll wind up somewhere on this line. That's kind of neat. Okay, well, I will be talking about derivatives in the next video, which really is slope, but we're not going to limit that discussion to lines. It will talk about how derivatives can be really informative about curvy lines like parabolas and all kinds of curves. Thanks for watching.